Hey everybody. So you're presented with some data and you want to know where to start. It's always a good idea to start by visualizing your data. Before you even calculate a single statistic, before you calculate the average or the range, or you look to see what the high values and the low values are, graph your data. Now the particular kind of graph can vary, that depends on context. But you should almost always just start by looking at the data. You'll understand a whole lot more about what's going on than what any one particular number can give you. Now here's an example. You've got this data. Well, at least there's a title. That's good. You know that it's 2018 unemployment data. But what's your state's number there? And is it a good number? Is it a low unemployment rate or a high unemployment rate? Where do you stack compared to the nation? Where do you stack compared to your region? Are you above average or below average? Are you way out in the tails, like way above or way below average? Now you can answer all of these questions if you run enough statistics on it and make enough calculations. But a simple graph can usually answer a lot of your questions. Now again, the type of graph will depend on the kinds of questions that you want that data to reveal. So first of all, I like this. This is not a graph, it's just a table, but at least now I know what the numbers correspond to. I can see that the numbers were alphabetical by state name, that's good. And I can see that my state, Louisiana, has a 4.9% unemployment rate. I still can't exactly tell, though, whether it's high or low for the US or for its region. But this picture helps. So here we've got a picture of the US, and every state is kind of color-coded. This is called a choropleth map, or sometimes called a heat map. And we can see that the dark blue cells have an unemployment rate of 4.3 all the way to 6, and the ones that are really lightly shaded or even unshaded, those have unemployment rates between 2.5 and 3. So if you wanted to know where Louisiana was, you could just see, well, look, it's dark blue, which means it's among the worst for unemployment in the country. And if you look at the Gulf South region, the only neighbor that seems to match it is Mississippi. And, you know, every Louisianian always says, thank goodness for Mississippi, because sometimes they don't make us look quite so bad. So this is a nice little graph. I mean, it shows you a whole bunch of information that, frankly, is just not obvious, even with that table. Lots of nice detailed information in the table. I mean, if I wanted to know what Vermont's specific unemployment rate is, it's nothing better than a table. But if I want to know about the geographic clustering of unemployment rates, this picture is the way to go. We can see that in the central Midwest there, the upper Midwest, I should say, you know, Minnesota, Iowa, Wisconsin, very low unemployment. So there seems to be a lot of clustering. The Gulf South almost always has high unemployment. The West Coast, higher unemployment than average. This really wouldn't have been obvious at all if you had just stared at the table. Now, there are other graphs that we could have drawn. So for example, this picture is called a frequency histogram. And this tells us how often, what frequency, how often a particular value occurs. Now we just kind of lump them together into groups, but we can see that, you know, the most commonly occurring value seems to be around, well, you know, somewhere between 2.5% and 4.5%. So almost everything happens in this area. There's a couple of outliers there. Who knows? That might be Louisiana. But we can definitely see what the average is for the entire country. We can't see regions anymore, but we can see for the entire distribution of unemployment rates what that distribution looks like. It looks like it's a little skewed. It kind of has a long tail here on the right, but otherwise it's fairly symmetric. And it's got a fairly well-defined center. So like the average would be a nice statistic to follow this up with, just to know exactly where that average is for for the United States. Right? So drawing the pictures, I think, is really useful. And frankly, your readers have a very limited attention span. Much like you right this second. You're wondering if I'm getting any place. I am. You have to grab your readers. They only give you a few seconds worth of attention. This picture conveys a lot of information in a short amount of time, and so does this one right here. A whole lot more information than the table, because they're not going to study that. A lot of people will just skim past that. So I encourage you to graph your data. A related graph, by the way, is a relative frequency histogram. So the pictures really show the same information. It's just the axis that's different. In a frequency histogram, it tells you how many particular number of times something happened. A relative frequency histogram shows you the percent of times that something happened. So it really is just a rescaling of this y-axis, the same kind of thing. So the histogram, these two graphs that I just showed you, or these frequency histograms, are great for showing you the distribution of something. You can kind of see where the center is. You get an idea of whether it's tilted in one direction or another, or if there's a long tail. That's skewness. It tells you whether there are particular values that occur a lot more than others. All this is just obvious when you're looking at a picture. You would need, to compute a different statistic for the center, maybe the mean or the median. You would need to compute a statistic for symmetry, a statistic for skewness, a statistic for modality, and a statistic for spread and all that, maybe even more than one for spread. Those are nice, precise numbers. Maybe you don't need precision. Maybe you just want to get like the overall sense of something. One picture conveys all of that information. Now, I've got a video which you're going to watch next on the differences between frequency tables versus histograms. A table is just a tabular way of doing the histograms. And really, they're just bar charts. So that's what the video is on, is actually bar charts versus histograms. Just a different name for the same kind of thing. So histogram is for numerical variables, and bar charts are for categorical variables. It's the same idea. It's a bar chart. It's just a bar chart. The general process for making a histogram, you've got to divide up your data into discrete bins. So maybe you could have a 1% unemployment bin. It goes from 1 to 1.9, and then the 2s, and then the 3s, and then the 4s. Now that's up to you how many bins you're going to have. The bin width should be the same, so you shouldn't have, from 1 to 2, 2 to 3, 3 to 5, 5 to 5.5. I mean, that's just kind of shenanigans. It happens, but you shouldn't do that. So divide your data set into these bins, these little buckets, and then see how many observations belong in those buckets. And then just count the number of times. That'll give you the frequency. If you divide by the number of observations, like you divide by the 50 states, that'll give you the percent or the relative frequency. Right? And then you just draw a bar chart. That's it. That's all a histogram is. It's up to you how many bins to create. And again, you need to watch this next video about you can overdo it and underdo it. If you overdo it and you got way too many bins, your data set starts looking like a barcode. And if you've got too few bins, everything falls into one bin. That doesn't tell you anything. It basically just tells you there is unemployment, but it doesn't tell you anything else. So that's a trade-off you should be aware of. Now, one of those things that a histogram can show you is something called modality. Now, the way that statisticians use the word mode or modality, what it means is just a more frequently occurring value. Right? So the mode of a distribution is the one most frequently occurring value. A slightly different definition is that something is a mode if you have more observations happening at that observation than just a little bit to the left and just a little bit to the right. So, you might have a lot of states with a 2% unemployment. Well, not many. Let's say you just have a handful, but it's more than you have at 1.9 and more than you have at 2.1. In which case, that middle value would be a mode because it has more than its neighbors. That's all a mode is a value in your data that occurs more than its neighbors. Now, most nicely behaved distributions are unimodal. They just have one mode. I'll show you a picture of that real quick. These three on the top, they have one very well-defined, most frequently occurring value. Right? So each of these three on the top are unimodal. Now, not all distributions have one mode. These guys here in the bottom are bimodal. They have two modes. They've got this guy here occurs more than its neighbors, and this guy here occurs more than its neighbors. Right? Likewise, here we'll do this one. This guy here occurs more than its neighbors, and then this here occurs more than its neighbors. So we've got two kind of like frequently occurring values in your data. Now, I think modality is actually really interesting, not for its own sake. Modality can actually tell you something really interesting about your data. It's very often the case that if your data set has a very well-established bimodal distribution, two modes, probably means that you're mixing two different kinds of distributions. Right? So a classic example of a bimodal distribution would be the distribution of height. If you graph how frequently occurring, you got 6-foot people and 5-foot people and 5.5-foot people, 7-foot people. The distribution of heights is often bimodal. Well, that doesn't mean that you're like, well, kind of roll the dice. You either end up really, really tall or really, really short. It's not actually what's happening. What's happening is that men and women tend to have different heights. Men tend to be a little bit taller than women do. And so when you graph two different relevant populations at the same time, you're catching the peak of one and the peak of the other. You're just putting them in the same graph. And so you'll get that bimodal kind of distribution for height. If you see a trimodal distribution, think the same thing. Am I mixing three different groups? If you have more than three modes, I can almost guarantee you're not mixing 4 different populations or whatever. It just probably means that your bin width is really, really too small, and you're just capturing noise in your data. Right? So it just randomly could have had, a couple people who were taller than usual, and they just kind of stick out in the distribution. So I wouldn't read too much into 4 modes or anything more. 3 modes, you're just kind of on the border, maybe skeptical. 2 modes, consider it, very carefully. You could actually be seeing something very interesting in your data if you have 2 modes. Now, these histograms that you're looking at also show you something interesting about skewness. So here we've got a left skewed distribution, meaning its tail is to the left, and a right skewed distribution, meaning it's got a long tail to the right. Probably the most famous distribution for being skewed like this, here let me advance one slide, is something like this. This is the income distribution in the United States. It is not your usual standard bell-shaped curve. It's not. It looks more, in fact, it is this. It looks like this. It has a really, really long tail. Because frankly, you can't have like income much less than 0. I suppose you could be owing people money, but there's a practical limit to how much money you can owe somebody. But there's no practical limit to how much money you can have. Jeff Bezos or Bezos or Bezos. He's way out in those tails. Warren Buffett and Bill Gates, way out in that tail. All those tech people, making billions. they're like massively out into this tail. The rest of us, here. All right, so visually, then you can see that there's a lot of income inequality, and that's revealed in the skewness. You don't need a number. You don't need a fancy calculation for income inequality, a Gini coefficient or something like that. Just look at the picture. That long tail will tell you that there's income inequality. Now let's switch to some tips on how to make an effective bar chart, because really what we're doing is looking right now at a bunch of bar charts. You can say that try to keep your bars proportional. A lot of people play fast and loose by not just varying the height of a bar chart, but also varying its width. It's kind of a well-known trick in statistics circles. You'll see it here in just a few moments, that it can totally skew what a reader picks up from the data. You can kind of mess with people this way. You should also, of course, keep your axes proportional. It's really nice if you want precise data to just put a little number above each bar that tells you the exact value, in case that's important to your readers. Just having that number there is very useful. You don't have to like move your eye over to the axis and try to figure out exactly what that number is if it's just printed right above the bar. You can also say that in general, just don't clutter your graphs. There's one thing that really typifies students or people who are inexperienced with data, is they want to put everything into a graph. I understand the temptation. Don't. Try to think of what that one or two crucial pieces of information are that you want your reader to get, and have that guide your decision about what's essential and what isn't. And cut out everything that is non-essential. So I came across this slide deck online just not too long ago. It's this company called Dark Horse Analytics. And they had this really nice presentation about how there's way too much clutter in bar charts. And it could just really simplify things. So here we've got calories for a bunch of different foods. We've got French fries, potato chips, bacon, pizza, and chili dog. Now, what is it that you want your readers to have? If it's just they should have exactly the number of calories, just list it or put it in a table. Presumably, when you drew a graph, you were trying to like point out something in particular. Now, I think the pretend client in this slide deck is the bacon industry. Let's see what Dark Horse comes up with on trying to simplify this graph. The first thing is they got rid of the background, because why is that there? Just because you can do it doesn't mean you should. All right, then they removed some more backgrounds. They got rid of some redundant labels. All right, you don't need a legend if all that information is already on there. Excel will want to put a legend. You can delete it. You should. All right, let's get rid of even more. Number of calories. It already says calories on there. You don't need to say it twice. You didn't need to say types of food, because there it is. Those are foods. I think you can figure that out, that it's foods. Removing the border, because that's unessential. You can make things lighter. Remove all kinds of borders. Remove the colors. You don't always need to remove the colors, but if you want to draw your reader's attention to bacon, then only have that thing colored. They keep simplifying, right? Get rid of those shadows and all this nonsense. It's from like the 1980s. Just because a computer lets you do it doesn't mean you should. You get rid of those special effects. Get rid of the bolding. Lighten the labels, because those aren't essential. You don't want to give the same weight to this stuff as you do to bacon. You got to give bacon its own. All right, so they're lightening the lines. Heck, you can remove the lines if those aren't that important. Right? Keep simplifying. Here we talked about putting the number. See, we don't need to have lines with values there where you can like, figure out, that looks like 530 or something like that. Don't make things hard on your reader. If they need to know the number, put it there. 533. 542. Very close, but visually I couldn't tell the difference. Now I can. All right. So that's the lesson. Less is more effective. This picture, man, that might just be exactly what your reader needs. A very nice, simple graph. Right? I can pretty much guarantee that the reader of this, the person who's just glancing at this, thinks, oh, our bacon is, it's right in the middle there between pizza and potato chips. It's not too bad. Whereas, if we had started out with that horrible, over-cluttered piece of work, I don't know, man. I think a lot of readers would just look at that and go, and like scroll away. All right, so if you want to be an effective communicator of information, of data, you can't just use the defaults on Excel or whatever graphing software that you're using. You really have to pay attention to what information you want to convey to your reader and then tailor your graph to that. Line charts are probably the second most common type of chart that students want to draw. The other one is the pie chart. Oh, I hate the pie chart. We'll come back to that in a second. Line charts, right, just shows you the trend of something over time. Only do line charts if something is changing over time. Don't do a line chart if you've got a scatterplot, a cross-sectional data set, where someone says, what is the average, what is the GPA for every one of your students in class? You can't connect those dots. There's no meaningful order there. So only use a line chart if you have time series data. Be careful about your origin. You'll see in a couple slides from now that you can really mess with your users or your viewers' perception of data by messing with the origin, and it's a really classic trick to do in time series. As always, avoid your clutter. You may want to have markers for each value. I don't think so. I think that's clutter. I would say another thing is don't make your lines way too thick. Here, I'll give you an example. So these two pictures show you the same data. It's real GDP per capita. One thing for sure stands out. Whoa, that's the coronavirus recession right there. That's a big one, man. That's double what went on in the Great Recession. So this is serious. But just imagine that you were presented with the data, the picture on the left. Now, what can you do with that? I don't know. It's a little cluttered. What is it we want our readers to come away with? That's up to us to decide what they come away with. And frankly, I think the really important thing here is the drop from the coronavirus recession. Particular values are far less important. So that picture is, I think, a whole lot cleaner if you get rid of some detail. Right? So here, I like how you can tell it went from almost 60,000 down to almost 50,000. That gives us a sense of magnitude. So I like those numbers being there. But I don't really need to have all these intermediate values, the 55s, the 45s, and so forth. And I certainly don't need these lines to be that dark. Right? It's not like, it's unlikely, I should say, that I want my reader to know exactly what income was in 1990. And then I go up and I see there, and so it looks like it was around 37,000. I don't think that's what I want from my readers. What I want my students to know is that coronavirus recession. So I don't need to have all that detail with all these lines here. I just want that to be visible. In fact, I may want to even focus on this part. Maybe even highlight it, circle it, something like that. And it's up to you. I can't tell you exactly how to draw your picture. because the right picture really depends on context. Scatterplots. Scatterplots are really great for showing you the relationship between two variables. Right? Not one variable over time, between two variables. Right? And only two, because you can't really draw a three-dimensional picture, three variables. So one x variable, one y variable, plot those points, and then you can just see visually whether there's some kind of relationship. Doesn't necessarily show causation, it just shows that there's something there, there's some kind of relationship. Whether x causes y or y causes x, we can't tell from a picture. But here, this is, I think, kind of a nice little useful scatter plot. This was my grade distribution for microeconomics. Well, the grade distribution, final grade versus attendance. So this is kind of one way that I can try to tell my students, you know, you should attend class. Can't say for sure that it's causal, that if you attend, you will have a good grade. Could be that you tend to be good students, so you attend and you do well. Don't know. But do you want to risk it? I hope not. Right. So this shows you a very nice relationship there between as attendance goes up, final grade tends to go up too. And then here we've got just some other random examples of scatter plots. And these show you a very tight relationship between quant score in the SAT and verbal score in the SAT. A loose correlation, even looser, and then this, hard to see anything there. Hard to see anything at all there.